So today we're going to be talking about translations and translating a graph on a coordinate grid and what this translation does for the graph and its function. So what is a translation? Let's think about a basic definition completely separate from math. Think about when I translate a phrase in English to a phrase in Spanish. What changes and what stays the same? Let's just demonstrate this idea using Google Translator. So if I go into Google Translate and I'm going to translate the phrase, school is fun, from English into Spanish. My English phrase was school is fun. My Spanish phrase was la escuela es divertida. So you'll notice that when we translated an English phrase to Spanish, the only thing that changed was the language it was written and spoken in. But the meaning and the message that we communicated stayed exactly the same. And that's the same thing when we translate in math. A translation in math uses the same idea as translating words in other languages. This translation in math is when an object is moved a certain distance on a graph. When we do that, the shape and the size of the object doesn't change. The only thing that changes is its position on the graph. So let's demonstrate this. Here you'll notice that I took the basic graph of a parabola and I translated it by moving it along the x-axis. It still looks exactly the same. It's the same size and the same shape. The only thing that changed was its position on the graph. We're going to talk more about this later. So there's two types of translations. The first is a vertical translation that moves the graph up and down. And the second is a horizontal translation that moves the graph right and left. Today we're only going to be looking at vertical translations and what that does to the graph and to the function. So what exactly does this look like and how is the function of each graph being affected? We're going to use Desmos to demonstrate this for the function. So in Desmos, the first thing I'm just going to do is I'm going to go ahead and change my, my screen size so that it makes it a little bit easier to see. Now I'm just going to put a basic function into my graph, let's say 3x squared. And you'll see that this parabola, this is just our basic function. Now to this parabola, I'm going to add a plus k. And all this does is tell my function that I'm going to be adding a value to the end of the function. It's not actually affecting it. And I'm going to add this slider, and that's going to let me move my function along the y-axis. So to start, I'm going to keep my k at 0, meaning that the function hasn't moved at all. It's still exactly where I wanted it to be. And let's use this slider now, and I'm going to move my graph. And you'll notice that as k becomes more positive, my graph is going up on the y-axis. And once I move k back to 0, when it becomes more negative, my graph is going down on the y-axis. So as you can see from my examples, when I add a value onto the end of my function, my graph is translated up on the y-axis. And when I subtract a value on the end of my function, my graph is translated down on the y-axis. So let's go back to the original function of 3x squared. I'm not going to add any k to the end of it. And let's say I want to translate my graph 3 units up. I would just add a plus 3 to the end of my function because that's telling me that I want to move it up. My original function is still this blue one. Its size and shape stayed exactly the same. The only thing that was affected in this orange one is that it moved up on my y-axis 3 units. Now, likewise, if I wanted to move my graph down, let's say 6 units, I could add a minus 6 to the end of my original function. And you'll notice again that my blue function is my original and the size and shape stayed exactly the same. The only thing that changed is it moved down on my y-axis. So let's go back and do a quick recap of what we learned today. The first thing is that a translation doesn't change the physical shape or look of a graph. It is only a movement within the coordinate grid. And a vertical translation moves the graph up and down on the y-axis. So when I translate a graph up a certain number of units, I add that value onto the end of the entire function. So for example, if I want to translate the function f of x equals negative 5x squared vertically 9 units up, I would still have my negative 5x squared, but I would add 9 to the end of the function. And if I want to translate a graph down a certain number of units, I subtract that value to the end of the entire function. So if I want to translate negative 8 to the x vertically 4 units down, I would still have negative 8 to the x, and I would subtract 4 units. So negative 8 to the x minus 4.